You may remember that we said we could use carbon to reduce metal compounds, usually iron or copper. There are other metal compounds from these metals in the list that are too reactive, so carbon can't be used to obtain these metals. We have to use electrolysis as a method, and that's what we're going to be looking at next. Electrolysis is a way of splitting up compounds and making them into their elements. So if we have aluminium oxide as our compound, we can split it into aluminium and oxygen in this electrolysis. Things to notice about this electrolytic cell: the electrodes are made of carbon. That's the positive electrodes where the oxygen collects. And the cell wall is lined with carbon as well, and that's where the aluminium collects. Aluminium oxide is made from two kinds of ions: aluminium ions, which are positive, and oxide ions, which are negative. The aluminium ions are going to be attracted towards a negative electrode, which is lining the cell. A reaction happens here. The oxide ions, which are negative, are going to be attracted to the positive electrode, and again a further reaction here happens to produce oxygen. This reaction will only work if the aluminium oxide, normally a solid, is heated to a high enough temperature to melt. Cryolite is a substance added to this mixture in order to help it melt and lower the melting point. Once melting, the ions, oxide ions and aluminium ions, can move freely around to the electrodes where they make contact, and electrode reactions happen to turn them back into their elemental state. The most important reaction is the negative electrode, called the cathode. The aluminium ions gain 3 electrons to become aluminium atoms. So we say that the aluminium ions are reduced. A second complementary reaction happens when the oxide ions come into contact with the positive carbon electrode, and here they lose electrons. So we can see what happens. We have 2 oxide ions which become an oxygen molecule and give up 4 electrons. That's quite an important reaction to try and remember. It's 2 oxide ions producing an oxygen gas molecule. 4 electrons are released, and we say the oxide ions have been oxidized. In summary, aluminium is produced inside the cell and liquid aluminium is poured out at the end. The processes which produce the aluminium are: reduction is the gain of electrons, the aluminium ions gain electrons, and a second process called oxidation. Oxidation is losing electrons, and the oxide ions lose electrons to become oxygen molecules. As we can see from this picture, large amounts of aluminium are produced. This is a huge vat of liquid aluminium being poured into these ingot molds. This person here gives it some scale. The problem is that large amounts of aluminium need large amounts of electricity to make it, and that increases the cost. The solution has been to recycle more. Recycle waste cans, and now that's a very popular thing for people to do. Another important idea to reduce the cost of making aluminium is to add cryolite, which lowers the melting point of the aluminium oxide, and that means less heating is required, less fuels, so less cost. Electrolysis can be demonstrated in the lab with a low melting point substance like lead bromide. Lead bromide is made from Pb2 plus ions and 2 Br minus ions. The Pb2 plus ions are going to be attracted to the negative electrode. That's the cathode. And the reverse will happen with the bromide ions, which are going to go to the anode over here. At the negative cathode, the lead ions gain 2 electrons and become lead atoms. This is reduction. Reduction is gaining electrons. At the anode, 2 bromide ions lose an electron each to become a bromine molecule, Br2. 2 electrons are lost. And that is oxidation. Oxidation is all about losing electrons. The bromine that's formed is a brown gas and appears bubbling off around the anode over here. The process only works if the lead ions and bromide ions are able to move around in the mixture, so it must be molten. Electrolysis doesn't work if the ions can't move. After the process is over and the solid here has cooled down, then a little piece of lead can normally be found in the bottom. Electrolysis in this case has been used to make lead. One final point to note: bromine as a gas is poisonous, so the experiment should be done in a fume cupboard.